Hello, we're Group 5. We're going to be presenting to you a motion controller hammer. The project team, there's myself, Taylor, as a designer and information gatherer, Isaiah, who's a 3D modeler, builder, and programmer, and finally we have Nicholas, who's the designer, builder, and component manager.
So the problem with our motion control, which we were trying to solve the problem of, was basically we wanted to create a more accurate motion control. Basically, one that would not run into the problems that we noticed had happened to motion controls prior. Specifically, the Joy-Cons was our reference point because in the Joy-Con example, you could do movements up and down fine, left and right fine, up on a diagonal and up on a diagonal on the left or right, but down on a diagonal sometimes would read as a different motion, usually up on the same diagonal in the opposite direction, or it could read it as a side swing or downswing. So it wasn't as accurate as we would have liked, so we used that as the basis of our idea to create a more accurate motion control. So as for the competitive landscape for our motion controller, we looked at what competitors have existed over the last 15 or so years. So our first major competitor would obviously be the Wii Remote, which is their motion controller that started the motion controller craze. And then our more really contemporary controller competition would be more specifically the PlayStation Move, because those are very important controllers, especially for VR stuff with the PlayStation VR, and the Joy-Cons, which are the bigger competition, and they are essentially the successor to the Wiimote, and what our design is trying to fix the flaw of. And this is a difficult competitive landscape to break into because our controller is a single button controller, whereas these controllers are multi-purpose for more than just motion controls, which limits what our controller can do and what games our controller could be used for, potentially, making it a little more difficult to break into the market. So, for our SWOT analysis, we examined the strengths of our device versus weaknesses and opportunities and potential threats. So, our big strength we saw was that it's simple and easy to use, having only one button to focus on. So a weakness, it's very limited to what it could be used for. It's basically stuck to being only used for motion control based games or games where you could functionally do the gameplay with a single button. Now, for opportunities, this controller would actually be perfect for VR use, and it's not something we initially envisioned because we envisioned it originally as just for motion control based games, but it actually convert very well into a VR controller to base like weapons kind of thing. And as for threats, any pretty much other motion controller on on the market, because of our limited scope and focus on weapon movement, basically the Joy Cons, the Move, and really any other motion controller which is more general purpose compared to our hammer, which is ultra specific. Okay, so as for results of our SUS survey, so for our SUS survey, we surveyed 6 people. Uh, we found actually that most people really liked the controller. For the most part, our only negative feedback was that it might be too simple for some games. With it only having one button, it might not be able to do that, and we recognize that could be an issue in our design because we're by having only one button that severely limits what type of games it could play. However, for its intended purpose and ease of use, it flashed with flying colors, which makes sense because naturally one button makes it very simple to use, and it's very easy to understand because of its shape like a hammer. Moving on to the overall results. So, from our SUS survey, we averaged out between the 6 people to a score of 73.5 ish overall. And that's our results. Okay, so key takeaways. So the key takeaways we took from this is the design process is never ending. Up until the last moment, we were iterating and making changes. We went from initially a Wii remote like TV remote design to a sword like design, and then even later to our final design, which is reminiscent of a hammer. So the design process is almost never ending. You may think your design is going one way, and that may end up going a completely different way in the end. So another takeaway is we should take into account component sizes as more accurately because we ran into some issues with just the sizing of things in our final design. But overall, we did okay. We should do better in the future. General organizational things so we could get things done quicker. Uh, and physical prototypes, we probably should have made them earlier, some of them, because we needed to make more to, and we would have been able to catch more of these issues, like our final design not quite fitting perfectly. We might have been able to catch had we built one sooner and then made another iteration immediately after recognizing the issue. The other big problem was we needed to wear gloves because when soldering, because we realized that by touching the microchip when we were putting together the assignment breadboard thing, we realized that soldering actually does not interact well with oils from human skin, so we can't physically touch it with our hands unless we want it to be very difficult to solder. And we learned that the hard way on the first one, whereas the second two, which we hadn't touched, were much quicker. And overall, having clearer design priorities and design choices would be beneficial. And that's all the key takeaways.
All right, so for the interactive scene, it consists of three things on the screen. There's a indicator for is blocking. So basically, if it says is blocking no, that means you haven't clicked on the button. So if you press the button, it will say yes, but then if you let go, it will say no. And then at the center, there's a grid with a mark on it, and the mark will move accordingly depending on how you move the hammer. And then at the right side, there's the light. So basically, a mark will appear if the hammer is on.
That's all. Thank you for watching.